In this video, we'll tell you all about the feedback which can come from an exoskeleton and how it can be used. We'll make a distinction between feedback to the pilot and to the bystanders. But first, let's explain what type of feedback we are going to talk about. There are different types of feedback. In this video, we'll make the distinction between feedback that the exoskeleton gives to the pilot and bystanders, and feedback which the exoskeleton gives to itself. As the pilot cannot feel their own legs, feedback to the pilot replaces this internal feedback and informs the pilot on how the exoskeleton is doing. Feedback to the bystanders also informs them on how the exoskeleton is performing. Feedback to the system is what we refer to as internal data processing, but we won't discuss that in this video. The purpose of the feedback, which we discuss in this video, tackles several different reasons. The first one is to ensure that the pilot can understand what is happening in the exoskeleton. Then the second reason follows from that. If the pilot understands what is happening in the exoskeleton, they can learn from that and change their input accordingly. If the exoskeleton, for instance, gives a warning that a certain part of the exoskeleton is getting too warm, the pilot then knows that they might have to get out of the exoskeleton. That way, they won't get burned by hot surfaces. Remember, we already discussed some of this material in the video on safety, but this time we go into detail on the exact signals that are used as safety measures. Now, the reason for safety warnings applies to both the pilot and the bystanders. Say, for example, that the pilot or bystanders are warned by some kind of signal from the exoskeleton that the battery is almost empty. They can then decide to stop moving and change the battery. Without such a warning, the pilot could simply continue walking in the exoskeleton until the battery is empty. And that wouldn't be good. Finally, feedback from the exoskeleton can create trust for its users and bystanders. If the same sound, vibration, or movement happens every time we do something, it creates a predictability we can trust. Imagine if your phone wouldn't show a specific signal to tell you that it is charging. You would constantly have to check back to see if the battery percentage is actually still increasing. You know that the signal for charging means it is charging, and thus you can trust the battery to be charged. Now, an inexperienced pilot does not yet have much experience with an exoskeleton, and thus needs to learn a lot more from feedback, and needs to learn to trust the exoskeleton. These kinds of pilots might benefit from more feedback from the exoskeleton. At Project March, we work together with pilots who are used to walking in an exoskeleton, thus they don't require that much feedback. There are many different ways you could have your exoskeleton give feedback to the pilot and its bystander. Remember, we have 5 different senses, and for each of these, you can imagine a way this could be used to receive feedback. Some of these will seem more practical than others. A LED light would give a nice indication of how the exoskeleton is performing, but a different smell coming from the exoskeleton for each different type of gate might be less so. There are 3 different types of feedback which we implemented in the Project March exoskeleton. We have vibration in the crutch handle, which tells our pilot that a gate has been successfully activated. We have a sound system, which is designed to inform both our pilot and bystanders on the performance of the exoskeleton. The speaker for this is located in the backpack. Currently, it only makes a sound if a gate is about to start, if the pilot decides to stop a gate, or if a gate ends. Of course, we can also use the speaker for different purposes. But it is mostly used for safety reasons. Then there are several LED lights in the exoskeleton. Most of these provide feedback for the developers if certain components are active. There is one LED light which is specifically designed to give feedback to bystanders, and it is located on top of the backpack. In this location, it doesn't provide any feedback to the pilot, but we use it as bystanders to know how the exoskeleton is doing. If the light is on, it means the exoskeleton is on. Currently, we also have a system where the light then tells us how the exoskeleton is doing. If the light is blue, then the exoskeleton is idle. If the light is red, the exoskeleton is in error state. And if it's green, then the exoskeleton is executing a gate successfully. And then there's the feedback which we didn't intend to put in the exoskeleton. All of these signals are simply there because of the components from which we built our exoskeleton. There's the sound of the motors, which tell us both if they are working correctly and also if they're not doing so great. Then we have a lot of sensors in the exoskeleton, and in some locations we can see the light of these sensors telling us the sensors are working. The simplest feedback we as bystanders, however, get from the exoskeleton is how it is moving. If an ankle doesn't lift correctly, or if a part moves in an unexpected way, we can see it happening. But then how can we understand what is happening if there hasn't been any feedback to the pilot or to us bystanders in the ways we have just discussed? Well, that's when we take a look at the internal feedback the exoskeleton gives to itself. This is the data that goes on in the exoskeleton. We'll discuss how this data is analyzed in the next video. But first, make sure you understand the next assigned reading on how the exoskeleton acquires its data via sensors.